Hello and welcome to Legato's short topic training videos. These videos provide a quick look at various Legato features and functionality. This is the third video of 4 videos on program flow control. A common characteristic of most programming languages is to loop. Basically, loops allow a program to iterate or repeat certain steps or blocks of code. Legato supports 2 types of loops, while and for. In the later versions of Legato, we'll add for each and do, but at the moment you have while and for. The type that you use depends on the application and your own particular programming style. Whichever particular type of loop you'd like to use, they all have common control words. One is break, which will basically exit the loop and move up to the next brace level. And the next is continue, which returns to the top of the loop. All loops will have the following components, which may be part of the loop structure or just simply part of the surrounding code. There'll be an initializer. There'll be a loop condition test, and there'll be a loop iteration expression. The simplest loop statement is the while statement. The condition basically is tested, and if it resolves to true, it just simply continues to execute the block that is within the statement. And this will repeat as long as the condition is true, or while the condition is true. So our while example, basically I'm going to have an initializer. It's not part of the while statement. For example, here I'll have a word buffer and get the next word item out of a particular block. I'll then have my condition expression. So while WB is not equal to nothing, meaning that there's data, this particular function will continue to return data until there's no more data, and then it returns an empty string. I'll then execute a whole bunch of stuff, and then when I'm done, I have my loop expression. Notice that's not part of the statement, but I'm going to simply go get the next word block, and then this particular closing brace will cause the script engine to go back to the beginning and then test again and fall through. The while loop will continue while WB is not empty, or I break on a particular condition and then fall out. You'll notice there's also continue statements. Basically what we're doing here is we have another loop expression or an iteration expression, and then we're going to continue. It's actually really important to remember to do this when using a continue and a while loop, because if I don't do this, I'll get stuck in a continuous loop or never-ending loop, because WB will always be not equal to empty, and I'll just sit and go around and around and around. By the way, if you do end up in that condition within the IDE, you can always hit Control Break to stop the script from executing. The next type of loop expression is the for statement. This is a little more sophisticated. It's a variation on the simple while loop. It allows for built-in initialization. When the condition is tested, if it resolves to true, it'll continue to execute the block. And as it repeats the code inside the block, it'll run the iteration expression. So each time it loops through, it'll then run the iteration after it's done. So the structure appears as follows. I have the for statement, the initialization, the condition, the loop expression, and then the block of statements to actually execute. The init section allows for variables to be initialized. The condition section tests the expression prior to running for each cycle. And then the loop section is executed each time the loop cycles. It's important to note that in version 1 of Legato, the condition, initialization, and loop should be kept fairly simple. Do not use parenthetical expressions inside of the statement items here, because the parser has some issues with that at the moment, so keep this pretty simple. An example in practice, a segment of code. We're going to go get the array access depth, initialize a particular variable, so long as that's less than the size of that array. We'll continue to do this. Each time we do that, when it completes, it'll increment x. So I have my initializer, I have my condition expression, and then I have my loop expression. Now I can break out of this just like you can with a while, and if I continue, this loop expression will still get run, so I don't have to worry about saying x++. In fact, if you do x++ inside of here, you're going to mess up your loop, because it's actually going to skip and do 2. Which leads us to a stupid programmer trick that I have seen performed over the years. Adjusting the value of x within the for loop can be very dangerous. It is not uncommon for programmers not to realize that they are altering their test condition. This, in turn, results in some pretty bizarre and complex behavior. The possibilities of screwing things up are endless. This is not specific to Legato, but just a general bad programming practice. Whenever you're inside of a loop such as this, make sure that the variable being used to track the iterations is not altered unless that is specifically designed behavior. We touched on this earlier, but we'll go into it in a little more detail now, and that's the continue statement. Within a loop for a while or a for expression, the continue will cause the execution to move to the next iteration. So within a while, there actually is no built-in iteration expression or loop expression, so therefore you have to do that and then you continue. With a for, it's going to run the loop expression and then move on to the next iteration. So a script encountering a continue is basically the same thing as hitting the brace for the end of the particular block. And the continue can be nested inside of other blocks. It's always going to continue the block that it's in where there's a loop. If I say while and then if and put a continue inside of the if, it will walk back to the brace set that contained the loop and then continue. And then we have the break statement. Basically any place within a loop block for a while or for expression, the break will cause the execution of the block to end. It'll exit the loop. So the break basically exits the closest block with a loop or a switch. So within a switch, it's going to exit the switch. If I'm within a loop, it's going to exit that loop. If I have a switch within a loop, it's going to exit the switch, not the loop. If I move down to the next brace level, then it would exit the particular loop. So moving back to our first example with the while loop, we can see the different exit conditions. One is the WB, and the next is if Cx is less than 0, then break out of the loop. I also have the loop and test with my continues. And again, I have my loop expression when I iterate reloading WB. And that concludes part 3 of Program Flow Control.